Warm Caribbean water rests against you, clear and soft, as dawn spreads over the Belize Blue Hole. Below, the pale turquoise lagoon gives way to a nearly perfect circle of deeper blue. The edge is quiet, lined with coral, sand, and small fish moving through the morning light. But just beyond that rim, the seafloor seems to fall away almost straight down. This darkness is not a passing cloud or a trick of the surface. It is depth itself, held inside an old limestone opening at Lighthouse Reef Atoll. Long before the sea arrived here, rainwater moved through dry stone, slowly hollowing ruins and passages underground. Later, the roof gave way, and the rising Caribbean filled the empty space with still blue water. Now the circle remains, half reef and half memory, with ancient cave walls hidden beneath the calm. And as we drift inward from the bright rim, the strange story of this quiet blue well begins to unfold. The first thing you notice is how quickly the color changes beneath you. One moment the lagoon floor is close enough to read in patches of sand, coral, and waving seagrass. Then, only a short distance farther inward, the bottom seems to disappear into blue. This is the first concrete clue that the blue hole is not shaped like the lagoon around it. It's not a broad hollow, or a shallow basin, or a dip in the reef flat. It's a steep-sided opening, almost circular, about 300 meters across, and roughly 124 meters deep. That depth changes the water's color before anything else explains the place. Sunlight enters the surface, but the longer red and orange wavelengths fade quickly in seawater. Blue light travels farther, and where the water becomes deep enough, that blue gathers into a darker, quieter shade. So the circle is not painted onto the lagoon. It is the lagoon showing you where the floor has fallen far below. We stay near the rim for a while because the edge tells the first part of the story. Here, the water is still warm, and the light rests gently on coral heads and pale sand. Small fish move in loose groups, crossing the boundary between brightness and shadow without hurry. The reef outside the hole belongs to the living surface of Lighthouse Reef Atoll, one of Belize's great offshore rings of coral. But the center of the blue hole belongs to another kind of landscape. It belongs to absence. The shape is not made from something added. It is made from something removed. That is the decision point in this quiet descent. We can keep looking at the blue hole as a beautiful dark circle in tropical water, or we can begin to read it as an old opening in stone. So we drift inward, slowly, away from the brightest coral edge. The rim passes beneath you, and the shallow textures become less certain. The sand no longer shows every ripple. The coral shapes soften. The fish thin out slightly, not because the water becomes empty, but because the architecture beneath them changes. A reef spreads outward, full of ledges, hiding places, branching forms, and food moving through sunlit water. A vertical shaft offers something different. It offers space. It offers depth without much shelter. It offers a blue interior where the sides drop away and the floor waits far below. This abrupt boundary is why the Belize Blue Hole feels so strange even before anyone explains it. Natural places often change gradually. A beach slopes into water, a reef rises and falls in broken platforms. A river delta fans outward in slow, muddy patterns. But here, the eye crosses only a narrow distance, and the world becomes vertical. The lagoon says, "Here is shallow water." The circle says, "Here is a former cave." The difference is so clean that it almost feels drawn, but it was made by slow chemistry and time. That is part of the quiet wonder of it. The blue hole looks simple from above, but its simplicity is the result of many processes meeting in the same place. First came limestone, then came rain, then came hollowing, then collapse, then sea level rise. Then coral, algae, sediment, and still water. Each step left something behind, and each step erased something too. From above, all of that history is compressed into one calm circle. The morning sun spreads across the surface, but the dark center holds its shape. Ripples pass over it. Cloud reflections pass over it. Small waves wrinkle the boundary between turquoise and blue. Still, the circle remains steady because the cause of the color is not on the surface. It is below. As you float above it, you can imagine the water column as a quiet well, open to the sky. At the top, the Caribbean breathes in light and warmth. Around the rim, corals build and break, making sand from skeletons and shells. Inside the shaft, fine particles begin their long fall. They drift down through the blue, grain by grain, as if the whole is always collecting the day. This collection is another clue. A deep circular basin inside a reef does not only look unusual, it also behaves differently from the surrounding lagoon. The walls slow the movement of water, the depth changes the light, the shape gathers sediment. Over time, a place like this can become a natural archive, holding quiet records of storms, rain, reef life, and chemical change. But before it could collect anything from the sea, it had to become a hole. And before it became a hole, it had to become a cave. To understand that, we let the present surface fade a little, not completely. The warm water is still around you. The reef is still near, but the mind begins to travel backward, beyond the dawn, beyond the present lagoon, beyond the living coral rim. It goes back tens of thousands of years, when the world's ice held more of the planet's water on land. During colder glacial periods, sea level was much lower than it is now. The place beneath you was not covered by this clear Caribbean lagoon. It was exposed limestone, open to air, rain, roots, and slow weathering. The blue hole, in that earlier time, was not blue at all. There was no deep marine color in its center. There was no surface shimmer overhead. There may have been dry ground, low vegetation, and stone warmed by sun where the reef lagoon now spreads. And beneath that stone, water was already working. Rain fell onto the limestone platform. Some of it ran across the surface. Some settled into small cracks. Some carried dissolved carbon dioxide from the air and from soils, forming weak carbonic acid. That sounds sharp, but in nature it is patient and mild. It is the kind of acidity that works slowly, not by force, but by persistence. Drop by drop, it enters the stone. Limestone is made largely of calcium carbonate, the remains of ancient marine life compressed into rock. It can seem solid and permanent, but slightly acidic water can dissolve it over long periods. So the rain did not need to carve the blue hole in one great motion. It only needed time. This is a karst landscape, though from the surface today, the word is hidden beneath seawater. Karst forms where soluble rock, especially limestone, is dissolved by water moving through cracks and joints. The water widens small openings. Small openings become channels. Channels become chambers. Chambers may connect into cave systems, sometimes with ceilings, columns, and delicate mineral formations. In the ancient version of this place, fresh water moved downward through the dry limestone, following weakness in the rock. It did not know it was shaping a future landmark. It simply followed gravity. It found the little fractures where water could pass. Then it made them larger. This is one of the quietest forms of landscape making. No wave needs to strike, no river needs to roar, no mountain needs to break. Water enters stone and leaves with a little of that stone carried away. The change is too slow to see in a single day, or a season, or even a lifetime. But given enough years, the inside of the earth becomes less solid. It becomes honeycombed. It becomes hollow. It becomes ready to remember water. The strange thing about the Belize Blue Hole is that its present beauty depends on that older emptiness. The reef did not first make the hole. The sea did not dig it straight down from above. The dark circle began as a hidden interior, a system of voids created by freshwater in limestone when the land stood exposed. That means the Blue Hole is not simply a feature of the ocean. It is also a fossil landscape of dry land. It is a cave that the sea later inherited. The evidence for this older, air-filled world is not only in the shape, it is also in the formations found within the Blue Hole's walls. Deep below the surface, there are stalactites and other cave features. Stalactites grow from cave ceilings when mineral-rich water drips through air. They need open space. They need gravity pulling drops downward. They need a cave that is not full of seawater. So when we speak of stalactites inside the Blue Hole, we are seeing proof of a different chapter. Those forms could not have grown in the same way underwater. They belong to a time when the hollow was filled with air, not Caribbean blue. Imagine one drop of water moving through the limestone roof of that old cave. It carries dissolved minerals. It reaches the ceiling of an empty chamber. It hangs there for a moment. A little carbon dioxide escapes. A tiny ring of calcite remains. Another drop follows. Then another. Over a long time, a small tube grows downward. Later, it thickens. Later still, it may become a long, tapering formation pointing toward the cave floor. Nothing about this is hurried. It is architecture by patience. It is stone forming from water, while water is also dissolving stone somewhere else. That contradiction is part of what makes caves feel so ancient and strange. They are made by removal and addition at once. The blue hole holds that contradiction beneath its surface. Its walls speak of limestone lost to solution. Its stalactites speak of minerals redeposited in air. Its round opening speaks of collapse. Its present water speaks of the sea's return. Layer by layer, the place becomes less like a simple dark pool and more like a folded history of changing worlds. At the surface, the living reef says, "This is the tropics." In the walls, the old cave says, "This was once dry." In the depth, the blue water says, "This space has been flooded and stilled." That is why we continue inward, not downward too quickly, but mentally deeper into the cause. We pause above the circle and let the reef become a boundary. On one side, shallow coral grows in the light. On the other, the old cave drops beneath us. The decision to cross the rim changes what we are reading. We are no longer looking at a reef scene with an unusual color. We are looking at the surface expression of a collapsed caste system. This matters because the blue hole's strangeness comes from being out of sequence with the sea around it. The surrounding lagoon is a marine environment, built and altered by coral growth, waves, sediments, and shallow tropical water. But the hole itself was prepared earlier by rain and limestone dissolution under dry conditions. Then the ocean arrived later and filled an already made space. The result is a marine landscape with a dry land skeleton. The Caribbean surface above you is calm now, but the long history beneath it is not a single smooth story. It is a chain of changing conditions. Sea levels rose and fell across ice ages. Limestone was exposed, then covered, then exposed again in different places. Rainwater found pathways through the platform whenever the sea withdrew far enough. Caves grew in darkness beneath land. Some chambers enlarged, some ceilings weakened, some voids remained hidden, others became unstable. The blue hole is one of those places where the hidden interior eventually met the open sky. But that meeting came later. First, there was the cave. Let the present circle fade a little more. Picture the lagoon drained away, not suddenly, but by reversing time. The waterline lowers. The reef becomes a limestone platform. The soft blue center loses its color. What remains is pale rock, weathered and uneven, with cracks carrying rain inward. There may be shallow depressions on the surface, places where soil gathers and plants find a hold. There may be openings too small to reveal the chambers below. The true work happens underground, where darkness does not need the sea to be deep. In that older cave, the air would have been still. The walls would have held coolness. Water would have moved through the stone in threads and drops. Some passages might have been narrow, some chambers wide enough to hold shadows like rooms. As rainwater dissolved limestone, ceilings and walls changed shape. The cave did not have to be one perfect circle. It could have been a network, uneven and branching, shaped by joints in the rock and by the paths water found easiest to follow. But over time, parts of that network could widen into a large void beneath the surface. That void is important. A sinkhole begins not only with a hole above, but often with emptiness below. Stone can carry weight for a long time. Then, as support is slowly removed, the roof becomes thinner, more fractured, less able to hold itself. Still, nothing needs to feel abrupt from the perspective of deep time. A crack widens, a block settles, a ceiling arches, a chamber grows. The landscape above may look quiet for thousands of years, while the cave beneath changes grain by grain. This is one reason the blue hole's roundness feels so meaningful. Circular sinkholes often form where collapse spreads outward from a central weakness. The surface does not have to be carved evenly from above. Instead, The roof fails over a subsurface cavity, and the opening reflects the geometry of collapse. For the Belize Blue Hole, that round, steep form suggests a roof that gave way into a cave space below. The ceiling may have held for a very long time, even after the cave below had become large. Stone can be strong in compression, and limestone can span empty space longer than you might expect. But strength in a landscape is not the same as permanence. Every season of rain changed the roof a little. Every path of water through the rock widened some hidden weakness. Every tiny fracture gave the next drop a place to enter. And slowly, the cave roof became less like a solid lid and more like a thin remaining shell above an absence. The surface above may still have looked ordinary. It may have held pale rock, low plants, pockets of soil, and the quiet heat of a tropical day. But under it, the old cave carried a growing emptiness. That emptiness mattered because gravity is patient too. Gravity does not hurry. It simply waits for support to fade. A block of limestone loosens along a crack. A small piece falls from the ceiling into the chamber. Another piece follows after a long interval. The cave floor receives these fragments without sound in our imagining, because we are watching through deep time. There is no need for a dramatic moment yet. There is only the gradual rearranging of stone. As pieces fall, the roof becomes more uneven. As the roof becomes uneven, stress gathers around thinner places. The cave grows upward by collapse, just as it grew outward by dissolution. This process is sometimes called stoping, when material breaks from a cave roof and the void migrates upward. It is a slow way for hidden space to approach the surface. The cave is not only widening, it is rising. It is carrying its hollow shape closer to daylight, one fallen piece at a time, and above that hidden void, the land remains quiet. This is why sinkholes can feel so strange, even when explained gently. They are surface features with underground causes. They ask us to think not only about what rain and weather do to the top of the land, but what water does inside it. The Belize Blue Hole is a beautiful example of this hidden cause becoming visible. It is a round sign of a long, invisible process. It is the moment when underground space finally became part of the open world. The roof did not have to collapse all at once in the way a person might imagine. It may have failed in stages. One section could have fallen first, then another weakened edge could have followed. The circle could have widened as blocks broke from the rim and settled below. Over time, the opening would have become cleaner, steeper, and more stable. The landscape was adjusting to its new shape. The cave was no longer sealed. It had become an open sinkhole. In karst country, this kind of opening can be called a cenote, especially in regions where collapse exposes groundwater or an old cave chamber. The word belongs most famously to the Yucatan Peninsula, not far away across the wider Caribbean region. But the idea helps us understand Belize too. A cave can become a window, a hidden chamber can become a basin, and underground darkness can become visible from above. Before the sea returned, the open blue hole would have been a dry or partly water-filled hollow in exposed limestone. Its walls would have dropped steeply. Its floor would have held fallen rock, old cave deposits, perhaps pools of groundwater in the lowest parts. The air inside might have been cooler than the surface. Shadows would have settled along the walls during the day. Rain would still have entered, not only through cracks, but directly through the new opening. The cave was now connected to sky. That connection changed everything. Surface water could wash material into the basin. Sunlight could reach partway down. Plants might have grown along edges where soil collected. Animals may have visited the rim, though their traces are not the story we need to follow now. The main thing is simpler. The blue hole had become a container. It was an open, vertical space waiting for the next great change. That change did not begin at Lighthouse Reef alone. It began across the planet, in ice sheets far to the north and south. During colder periods, so much water was locked in glacial ice that global sea levels stood much lower. Large parts of the continental shelves and carbonate platforms were exposed to air. Reefs that are underwater now were dry rock then, or were shifted seaward to lower shorelines. The shallow Caribbean world we see today was arranged differently. The coastline was farther out. The water was held away. Limestone platforms had time in air. and rain had time to work through them. Then the climate began to warm. Ice that had rested on land began to melt. Water returned to the ocean. The sea rose slowly, but it rose with enormous consequence. It did not pour over the world in one instant, it climbed shorelines. It entered low places, it crossed flats, it filled channels, depressions, caves, and old valleys. It changed where waves could reach, where coral could grow, and where sunlight touched the seafloor. For the open sinkhole at Lighthouse Reef, the rising sea was the next inheritance. The old cave had been made by freshwater under air. The collapse had opened it to the sky. Now the Caribbean would enter it. We can imagine the first marine water approaching the rim over many generations. At first, the sinkhole may have stood above the waterline, holding only rainwater or groundwater in its deeper parts. Then the sea crept closer across the exposed limestone platform. Tides reached low channels, salt water entered cracks, the shoreline shifted inland and upward. Eventually, warm Caribbean water crossed the edge. A place that had known air began to fill with blue. The transformation was quiet but complete. The old cave formations, made in air by dripping mineral water, were submerged. Stalactites that had once pointed down into darkness now pointed into seawater. Cave walls that had dried and weathered became marine surfaces. The basin no longer held only rain, rock, and shadow. It held the sea. And once the sea entered, the Blue Hole became strange in a new way. It was no longer simply a collapsed cave, it was a collapsed cave inside a reef lagoon. That combination is rare enough to hold the eye. A circular shaft formed on land, then drowned by sea level rise, then surrounded by coral growth and tropical water. Each phase remained visible in some form. The round opening remained, the steep walls remained. The old cave deposits remained. The marine color arrived, the living rim developed, and the interior water became its own quiet world. The flooding also changed the chemistry of the place. Freshwater and seawater do not behave exactly the same. Freshwater is less dense, and seawater carries dissolved salts, including chloride, sodium, magnesium, calcium, sulfate, and many other ions. When salt water enters limestone caves, it can mix with fresh water in ways that continue dissolving rock. In some coastal cave systems, the mixing zone between fresh and salt water can be especially active. The chemistry does not simply stop when the sea comes in, it changes its method. But in the Blue Hole, the larger shape had already been prepared. The sea was not the original sculptor of the great vertical opening. It was the flood that revealed the old architecture in blue. As the water deepened, light began to behave differently inside the shaft. At shallow depths, sunlight still showed wall textures and ledges. Farther down, red light faded, then orange faded. Then yellow softened into blue-green. The old cave became a column of color. A dry sinkhole became a marine well. The deeper the water grew, the more the center darkened from above. This is why the Blue Hole's surface image is so powerful. It shows a geological past through a simple optical effect. Blue is not just a color here, it is a measure of distance through water. It is the visible sign of a floor far below. The rising sea also allowed coral to begin working around the rim. Corals need sunlight, clear water, hard surfaces, and warm conditions within their tolerance. The upper edges of the old sinkhole offered a shallow, stable boundary. Algae grew, small reef organisms settled. Coral larvae drifting in the water found places to attach. Over time, the living reef knitted itself around the old opening. This is another reason the contrast is so sharp. The reef rim is full of structures built upward by life. The center is a void, inherited from collapse. One is construction, one is absence, one catches light, one keeps depth. As we drift above the present Blue Hole, the two histories meet beneath you. The bright rim belongs to living coral and modern sea level. The vertical shaft belongs to ancient cave processes and collapse. The dark water belongs to the physics of light and depth. The stillness belongs to the geometry of the well. Nothing about the place comes from a single cause. That is why it feels so strange. It is a natural intersection. Freshwater made the cave, gravity opened it, the ocean filled it. Coral framed it, time deepened its silence. Now, as we begin to sink a little farther inside the circle, the surface brightness loosens its hold. The turquoise of the surrounding lagoon remains above and outward, but beneath you, the blue becomes more continuous. The rim no longer feels like a line on a map, it feels like a threshold in water. You are moving from the reef's open, textured world into the old cave's flooded interior. The walls are not always immediately close because the hole is wide. At about 300 meters across, it has room to hold a large column of water. You can imagine the sides falling away around you, steep and dim, not pressing inward, but defining the quiet space. The depth is roughly 124 meters. That is not the deepest place in the ocean, not even close. But inside a shallow reef lagoon, it is abrupt. It is enough depth to create a separate mood, enough to change light, enough to change circulation, enough to gather fine sediment, enough to make the water feel like an inward world. At the top, waves may pass over the surface. Outside, currents may move across the reef, but inside the shaft, movement softens. The steep walls shelter the water from some of the mixing that stirs shallow areas. The shape of the hole matters. A broad, shallow lagoon is touched everywhere by wind, sun, and tidal exchange. A vertical sinkhole communicates with the surface, but its lower layers can remain more isolated. Water can become arranged in layers. Temperature can change with depth. Salinity can vary subtly. Oxygen can become lower in deeper, less mixed water. These are not dramatic separations in the way a wall separates rooms. They are gradients. They are soft boundaries made by density, chemistry, and time. Still, soft boundaries can be powerful. If one layer is denser, it resists mixing with a lighter layer above. If deeper water is not often renewed, oxygen can be used faster than it is replaced. If organic matter falls into the hole, its slow decay can shape the chemistry below. The result is an interior that behaves differently from the reef just outside. This is one of the quiet secrets of the Blue Hole. Its strangeness is not only visible from the air, it is also felt in the water column. The descent becomes less about distance and more about layers. At first, you pass through warm, sunlit water where reef life belongs easily. Small fish can move across the rim, light reaches surfaces. Tiny plankton drift, particles shine briefly when they catch the sun, but lower down the light thins. The blue becomes less transparent and more surrounding. The walls may appear as darker suggestions. The surface above becomes a brighter disk, less like the world you came from, more like memory. The pressure increases with depth, but gently in this telling. It is simply the weight of water above. For every 10 meters of seawater, pressure increases by about 1 atmosphere. At the bottom of the Blue Hole, the pressure is many times what it is at the surface. But pressure is not something the place announces. It is part of the stillness. It is the steady embrace of the water column. Temperature can also shift. Sun warms the upper water most directly. Deeper water receives less heat and less motion. In many blue holes and marine sinkholes, the deeper layers can feel cooler, denser, and more withdrawn. The change is gradual, but your senses would notice it. The warmth at the rim becomes a softer coolness below. The water does not lose its Caribbean origin. It simply becomes separated from the bright skin of the lagoon. This separation helps explain why life changes with depth. Reef ecosystems are rich because they have sunlight, structure, circulation, and many sources of food. Corals host microscopic algae that use sunlight to make energy. Small fish feed, hide, clean, nest, and move among branching and massive coral forms. Sponges filter water. Algae grow on hard surfaces. Crustaceans occupy crevices. Everything is close to something else, but a vertical shaft offers less complexity as you descend. There may be ledges and overhangs in the walls. There may be old cave features and places where organisms can attach. Yet the open center has fewer hiding places, fewer sunlit surfaces, and less constant exchange. The deeper water is defined partly by what is missing. Less light, less movement, less oxygen, less reef structure. This absence does not make it barren in a harsh sense. It makes it quiet. The Blue Hole becomes a place where the eye rests on gradients rather than crowds. A few particles drift downward. A faint fish shape passes, and disappears. The wall holds shadow. The blue becomes deeper than color, and as you sink, the old story remains in the stone around you. The walls were once limestone ceilings and chambers. Some parts may bear the memory of dissolution, ledges, pockets, and undercut surfaces. The stalactites, now underwater, are especially important. They are not decorations added by the sea. They are evidence that this place once contained air. When explorers and scientists observed such formations within the blue hole, the interpretation became clear. The hole had not always been marine. It had been a dry cave system during lower sea levels. This evidence changes how we read the entire landscape. Without the stalactites, the round, deep shape might still suggest collapse. With them, the former cave is no longer just an inference. It is preserved in mineral form. The formations say, water once dripped through air here. They say, the ceiling once existed above an open chamber. They say, sea level has not always stood where it stands now. A stalactite is slow testimony. It grows in darkness, drop by drop. It records a relationship among water, air, limestone, and time. When it is drowned, it becomes a relic of changed conditions. Inside the blue hole, those relics hang in a marine world that did not exist when they formed. That mismatch is part of the strangeness. Cave forms belong to air, reef water belongs to sea. In the blue hole, they occupy the same vertical space. This is why the place feels like more than a scenic circle. It is a crossing point between climates, sea levels, and environments. A landscape that should have belonged to dry limestone is now held inside clear tropical water. A reef that should spread over shallow ground is interrupted by a deep collapse. A marine basin holds the shapes of an older cave. The present is layered over the past, without fully erasing it. Now imagine the ocean entering not in one clean line, but in stages. The first salt water may have pooled in the lower parts and mingled with groundwater. Tides may have pulsed through openings and cracks. Rain still fell from above, adding fresh water. Evaporation at the surface could have changed salinity in shallow pools. As sea level rose higher, the connection to the open Caribbean strengthened. The shaft filled more completely. Eventually, the rim became submerged beneath the shallow lagoon. At that point, the blue hole changed from an open sinkhole on land to an underwater sinkhole within an atoll. The rim became a place for reef growth. The interior became a place for depth. The whole feature became visible from above only because the water was clear enough to reveal color differences. Belize's offshore reefs are part of a Great Barrier Reef system, one of the largest reef systems in the world. Lighthouse Reef Atoll sits away from the mainland, surrounded by deep Caribbean water and built by coral processes over long spans of time. An atoll is a ring-like reef structure enclosing or partly enclosing a lagoon. In many parts of the world, atolls are associated with coral growth around subsiding volcanic islands. But carbonate platforms and reef structures can have complex local histories. At Lighthouse Reef, the blue hole sits within the lagoon as a striking interruption. It is not the atoll itself, it is a feature inside it. That distinction matters. The reef is the living frame. The blue hole is the inherited opening. Together, they make the landscape people recognize. The reef's pale shallows make the dark circle visible. Without the bright turquoise water around it, the hole would still exist, but its visual contrast would be less immediate. The pale lagoon is the page. The blue hole is the ink, and the ink is made of depth. As the sea continued rising after the last glacial period, corals adjusted by growing where conditions allowed. Reefs can build upward toward light, as long as sea level rise is not too fast for growth and conditions remain suitable. Coral skeletons accumulate, broken fragments become sand, calcareous algae bind and cement surfaces, shells, foraminifera, and other carbonate producers add their small remains. The shallow rim becomes a living and breaking edge, constantly made and remade, but the center cannot be filled so easily. The hole is too deep and steep. Sunlight weakens with depth, and coral reef growth is most vigorous in the upper photic zone, where enough light supports symbiotic algae. So the rim grows bright with life, while the central shaft remains open. The contrast sustains itself. Life builds around the absence, but not across it. That is a simple sentence, and it explains much of the blue hole's power. Life builds around the absence remains. Even sediment falling into the hole does not quickly erase it. Fine material settles at the bottom, but the vertical space above remains large. Storms may wash sand and organic matter inward. Everyday reef processes may send grains drifting over the edge. Plankton shells may sink, tiny bits of coral, algae, and seagrass may descend. But to fill a basin more than 100 meters deep requires an immense amount of time and material. The hole continues to hold its shape. It receives the reef slowly. Some of that material settles quickly if it is heavy enough to fall through the upper blue. Some remain suspended, moving in faint curls, as if the water is thinking before it lets go. The smallest grains may take a long time to reach the floor. They turn, drift, pause, and continue downward through a column that is much quieter than the reef. In open, shallow water, wave energy keeps particles moving, lifting sand and laying it down again. Inside the blue hole, the steep walls reduce that constant stirring, especially deeper in the shaft. So the falling material does not behave like beach sand in surf. It behaves more like dust in a still room, descending through a beam of light. This is one reason the blue hole can preserve traces of passing conditions. The water column is not perfectly sealed, but it is sheltered enough to slow the world down. A storm crossing the Caribbean may stir the lagoon above and wash new grains across the rim. A calm season may let finer material fall more evenly, without strong disturbance. A wetter period on nearby land may change the chemistry and sediment reaching coastal waters. A change in reef life may alter the kinds of carbonate fragments entering the hole. Each small delivery enters the same vertical space, then it begins the same quiet journey, downward, grain by grain, layer by layer. This is where the blue hole becomes more than a flooded cave. It becomes a collector, not a collector with intention, but a collector by shape. The circle catches what the reef and water give it. The depth protects some of what falls. The stillness limits how often the record is mixed again. And over long spans, the bottom becomes a soft archive of the surface world. The idea is simple, but it changes the feeling of the place. The dark center is not empty. It is receiving. It is storing weather in mud, reef change in pale grains, and time in thin layers. To read that record, scientists can study cores taken from the sediment. A core is a narrow column of mud and fine material lifted from the bottom with its layers intact. The upper layers are younger, the deeper layers are older. If the layers remain clear, they can tell a story in sequence. This is the same basic principle used in lake beds, ice cores, and deep ocean sediments. The quietest places often remember the most, not because they speak loudly, but because they are not always being erased. The blue hole's protected basin can preserve signals that a wave-swept reeflet might lose. Heavy storms may leave thicker, coarser layers washed in by unusual energy. Quieter years may leave finer, more even deposits. Organic material can reveal changes in productivity, oxygen, and decay. Chemical patterns can hint at rainfall, evaporation, and seawater conditions. None of these clues is simple by itself. A sediment layer must be compared carefully with other evidence, but the possibility is remarkable. A dark circle in the lagoon can hold traces of old skies. A hole made by vanished freshwater can remember later storms crossing the sea. A cave that became a well can become a notebook. And all of this happens because the place is deep, round, and relatively still. As you sink farther inside the water column, the reef above feels less like a surface and more like a rim. The bright corals are still there, but now they belong to the upper edge of the story. Below them, the blue hole becomes its own interior. It is not separate from the Caribbean, yet it is not quite the same as open water. It has a boundary made of limestone walls. It has a floor far below the surrounding lagoon. It has a vertical shape that changes how water moves. This is the next part of its strangeness. The blue hole is connected, but not completely mixed. Water can enter and leave at the top. Tides can move across the reef and over the opening. Wind can stir the surface layer, but the lower water can be slower to exchange. The deeper part of the shaft may hold water with less oxygen than the upper reef. That lower oxygen is not a mystery once the geometry is understood. Oxygen enters seawater mostly from the atmosphere, and from photosynthesis in sunlit layers. Waves and mixing carry oxygen downward where the water is well stirred. But deep, sheltered basins receive less of that constant renewal. At the same time, organic matter falls into them. Tiny bits of living or once living material sink from the reef and plankton above. Microbes break that material down. In doing so, they use oxygen. If oxygen is consumed faster than it is replaced, deeper water becomes oxygen poor. The process is quiet, chemical, and gradual. It does not need drama. It only needs falling organic matter, limited mixing, and time. Inside the blue hole, those conditions can meet. The upper water still belongs to the bright Caribbean. The lower water becomes more withdrawn. Some blue holes and marine sinkholes develop strong chemical layers, including zones with very little oxygen. In certain settings, hydrogen sulfide can form where microbes work without oxygen. That gas has a sharp smell at the surface, but underwater it is simply part of a chemical boundary. In the Belize Blue Hole, divers have described a distinct cloudy layer at depth associated with changes in chemistry. For our descent, the important point is not discomfort or spectacle. It is separation. The water is arranged into zones, as if the old cave still prefers rooms. Near the surface, light, oxygen, and reef life move easily. Farther down, the water grows darker, cooler, and less renewed. The same shaft holds both worlds. And between them, there may be a soft transition, not a door, but a veiled layer. A change in water can be visible when particles gather along a density boundary. It can look like haze. It can make the space below appear less clear. It can turn the descent into a passage through a quiet curtain. The reason is density. Seawater density depends on temperature, salinity, and pressure. Cooler water is usually denser than warmer water. Saltier water is usually denser than fresher water. Denser water tends to sit below lighter water unless mixing is strong enough to overturn it. Inside a sheltered vertical basin, these differences can persist. They are not fixed forever. Storms, tides, and seasonal changes can disturb them, but the shape of the hole helps them return. The walls and depth make the interior less like a shallow open flat and more like a standing column. This column has memory. It remembers not only what falls into it, but how its layers have been allowed to rest. The deeper you imagine yourself sinking, the more important stillness becomes. At the top, sunlight is busy. It scatters across small waves. It glances off fish scales. It makes coral sand bright enough to seem almost white. But here, lower in the blue hole, light becomes less active. It does not flash as much. It arrives diminished, filtered through many meters of water. Red is gone first, then the warm colors fade, leaving blue and green. Even those begin to loosen and thin. The world below is not black at once. It is a long gradient into dimness. That gradient is part of the sleep of the place. Nothing cuts away suddenly. Everything is reduced by distance. Color reduces. Sound reduces. The reef's bright complexity reduces into walls, water, and falling particles. You might notice now how the surrounding limestone changes the feeling of scale. The blue hole is wide enough that the far wall may be only a suggestion. It is not a narrow cave passage where stone crowds the body. It is an open cylinder, broad and calm with a hidden floor. That breadth gives the darkness a spacious quality. It does not close in. It opens downward. This is one reason the hole feels so different from a simple cave. A cave turns and narrows. A shaft descends. The blue hole holds the vertical directly beneath the sky. It is a place where the surface world can look straight into an older hollow, and yet, even with that direct opening, the lower water keeps its privacy. The sun can enter only so far. The wind can stir only so much. The reef can build only around the rim. The deeper interior remains mostly blue silence. As the descent continues, the history of the walls becomes easier to imagine. These walls are carbonate rock, shaped first by life, then by exposure, then by water moving through them. Carbonate platforms are built from the remains of marine organisms that produce calcium carbonate. Corals, algae, mollusks, foraminifera, and other small creatures all contribute over time. When sea level drops, these marine sediments can become dry limestone. Rainwater then begins the work of karst. So the blue hole begins and ends with the sea in a strange loop. Ancient seas helped make the limestone. Rain dissolved it when the sea withdrew, collapse opened it to air. The modern sea returned and filled it. Now reef life builds along its rim again. The place is marine terrestrial and marine again, folded into one landscape. This back and forth is not unusual for carbonate regions, but the blue hole makes it visible. Sea level is one of the great slow hands shaping coastlines. During glacial periods, water is stored in ice sheets on land, and sea level falls. During warmer periods, ice melts, ocean water expands, and sea level rises. These changes expose and flood shallow platforms again and again. Each exposure invites dissolution. Each flooding invites marine growth. Over many cycles, the same rock can be carved, drowned, built over, and exposed again. The Belize Blue Hole is a record of one especially clear sequence in that larger rhythm. It reminds us that a coastline is not a fixed line, it is a moving condition. A reef lagoon can become dry ground. Dry ground can become a cave country. A cave country can collapse into openings. Those openings can become flooded blue wells. And then, at dawn, they can look almost simple, a dark circle in pale water. This simplicity is what keeps drawing the mind back. From the air, the blue hole seems nearly perfect in shape. From the water, that perfection becomes a system of causes. Circularity comes from collapse into a hollow. Darkness comes from depth and light absorption. Stillness comes from shelter and vertical geometry. The living rim comes from shallow, warm conditions. The silent floor comes from trapped sediment and weak disturbance. Each feature answers a question, but each answer opens another layer. Why is it round? Because the roof of a cave system gave way. Why was there a cave? Because acidic rainwater dissolved limestone during lower sea levels. Why is it underwater? Because ice melted and the Caribbean rose. Why is the center dark? Because the shaft is deep and absorbs light. Why is it still? Because its shape limits mixing and gathers fine material. The strangeness is not one thing. It is the alignment of many things, and that alignment is rare enough to feel almost deliberate, though it is not. Nature often looks designed when many slow processes meet cleanly. A canyon may look carved by intention, but it is river, uplift, and time. A glacier valley may look sculpted by hand, but it is ice, gravity, and rock. The blue hole looks cut into the lagoon, but it is chemistry, collapse, and sea level. No single moment explains it. The explanation is a descent. It begins with rain, it passes through stone, it opens into air, it fills with seawater, it settles into blue. As you continue downward, the reef's sounds seem to fall away in imagination. Sound travels well through water, but the mood of the place is quiet. There is no surf noise down here in the same way there is at the surface. There is no bright crackle of shallow life in the mind, only the sense of distance from the wind. The surface above may be rippled, but those ripples are now just pale motion far overhead. A small particle passes near you, it catches a little remaining light. Then it turns out of view, another follows. This constant fall is one of the most important movements in the hole. Not fast, not dramatic, constant. Marine snow is the name often given to tiny drifting bits of organic and mineral matter sinking through water. In the open ocean, marine snow feeds deep ecosystems far from sunlight. In the blue hole, a similar downward drift helps connect the bright rim to the silent floor. The upper world sheds tiny pieces, the lower world receives them. Some are mineral grains from coral and shell. Some are mucus threads from plankton. Some are fragments of algae. Some are remains of microscopic organisms. Some may be storm-washed debris carried in during rougher weather. Together, they become part of the sediment record. The falling particles also influence chemistry as they decay. Microbes use organic matter as food. Their activity can lower oxygen in the depths. If oxygen becomes very limited, different microbial processes take over. The water chemistry shifts. The sediment chemistry shifts. Minerals may dissolve or form under these conditions. Even the color and smell of mud can change, though in this calm telling, We do not need to disturb it. It is enough to know that darkness is not inactivity. The deep part of the blue hole is quiet, but not frozen. It is processing what falls. It is changing slowly. It is turning reef life, storm dust, and plankton remains into layers. The deeper water may hold fewer visible animals, partly because oxygen and food conditions differ. Many reef fish prefer the bright, structured rim and surrounding lagoon. There they find food and shelter among coral heads, sponges, and crevices. Down in the open shaft, there is less to hold them. Some animals may pass through, some may use ledges. Some may remain near the upper wall, where light and oxygen are more favorable. But abundance thins with depth. This thinning is not a failure of the place. It is one of its defining features. The blue hole is strange because it contains a lively ring and a quiet center. It is a circle of contrast. Around the top edge, life is busy with small purposes. Inside, the water asks less of the eye. It gives space instead. A barracuda may hang near the upper blue, still as a silver line. Small fish may move along the rim and vanish into coral shadows. Sponges may cling to hard surfaces where currents bring food. Algae may grow where light still reaches, but farther down the old cave wall becomes less decorated. The living reef does not follow the shaft into deep dimness with the same intensity. Sunlight decides where the reef can flourish. The geometry decides where darkness begins. This is the boundary that makes the rim so vivid. Coral reefs depend on a partnership between coral animals and microscopic algae living inside their tissues. Those algae use sunlight to make sugars through photosynthesis. The coral receives energy from them, while also capturing tiny food from the water. Without enough light, the partnership weakens. So reef-building corals are usually limited to clear, shallow water, though exact depths vary. At the blue hole, the shallow rim provides what they need. The vertical interior quickly takes it away. This means the hole does not become a coral garden all the way down. It remains a flooded void. It remains a blue column below a living necklace. The contrast is a direct result of light, and light is a direct result of depth. Again, the surface image is tied to the hidden physics. The dark circle is not separate from the reef. It is made visible by the reef's brightness. The reef is not separate from the hole. It supplies material to the hole and frames its upper edge. Together they form a single system, divided by depth but connected by falling grains. If you could hover just inside the rim and look outward, the surrounding lagoon would look shallow and clear. If you turned inward, the water would deepen into blue. That turn is the whole story in miniature. Outward is construction, inward is absence, outward is coral growth. Inward is collapse preserved, outward is sunlit exchange. Inward is still collection. The blue hole asks the eye to hold both directions at once. That is why it feels more mysterious than a simple deep place offshore. The deep ocean is expected to be deep, but a deep circular shaft inside shallow turquoise reef water feels like a memory out of place. It carries an older landscape into a younger seascape. The ocean did not smooth it away. The reef did not hide it. The hole stayed open enough to reveal itself. Even the name Blue Hole is a plain description that becomes poetic by accuracy. It is blue because water filters sunlight. It is a hole because rock was removed and the roof collapsed. It is great because of its scale and clarity. The name does not need embellishment. The place is already enough. As we drift lower, the surface disk becomes more distant. It may shimmer above, widened by refraction and broken by small waves. The rim is now somewhere overhead and around you, less a line than a remembered circle. The water feels cooler. The blue feels darker. Particles are easier to notice because there are fewer other movements. They fall in different speeds, according to size, shape, and density. A coral sand grain drops more directly. A flake of organic material turns slowly, resisting the water. A microscopic shell may sink with barely visible patience. Some particles clump together, some separate, some are eaten before reaching the bottom, some dissolve partly on the way. Not everything that enters the hole becomes a permanent layer. This is important. An archive is never a perfect recording. It is a filtered record. It preserves some signals and loses others. Sediment can be disturbed by animals, currents, chemical changes, or later events. Layers can be compressed. Some materials decay, some are dissolved, some are too fine to settle where expected. So when scientists read a place like the Blue Hole, they do so carefully. They compare layers with dates, chemical markers, grain sizes, and regional climate evidence. They ask whether a coarse layer might represent a storm. They ask whether a chemical shift might reflect rainfall or oxygen changes. They ask whether a pattern repeats and whether it matches other records. The Blue Hole can remember, but its memory must be interpreted. That makes it more interesting, not less. A natural archive is not a printed page. It is a layered conversation between environment and preservation. The bottom receives what the upper world delivers, but it also changes that material after burial. Microbes continue their quiet work. Minerals react. Organic matter breaks down. Fine layers compact under the weight of newer sediment. The record becomes denser with time. That density is not only physical but historical. A thin slice of mud can hold a season, while a deeper slice may hold a century. The Blue Hole keeps these slices in a place where waves cannot easily scatter them. That is why the stillness matters so much. Still water does not simply look peaceful. It protects delicate order. If the same material fell onto a shallow reef flat, much of it would be lifted again by waves. It would roll, break, dissolve, and move away. But inside this steep basin, the energy fades with depth. The hole becomes a settling chamber, open above, guarded below by quiet geometry. This is one of the clearest consequences of its shape. The circle is not only beautiful from above, it is functional. It catches the small remains of the surrounding world and lowers them into shadow. So when we speak of the Blue Hole as strange, we are not only speaking of its color, we are speaking of how a single landform changes the behavior of water, light, life, chemistry, and time. The old cave became a machine for stillness. Not a mechanical machine, of course, but a natural one. A form that causes certain things to happen again and again. Water enters, particles fall, layers settle, oxygen declines in the depths, the bottom keeps receiving, the rim keeps living, the deeper interior keeps remembering. And because the opening is so clean, so round and so steep, the contrast remains visible. The reef does not slowly slope into darkness. It steps away. That step is the old collapse, still present in the modern sea. As we hover deeper in the water column, the rim above begins to feel almost distant. The coral ring is still part of the place, but it is no longer the center of attention. Now the center is the descent itself. The water here has fewer interruptions. It gives you time to notice the small differences that define depth. A tiny shift in temperature, a darker shade of blue, a softness in the light, a slower pace to each drifting grain. The Blue Hole asks for this kind of attention. It does not explain itself all at once. From the air, it gives you the outline. From the rim, it gives you the contrast. From the deeper water, it gives you the mechanism. The stillness is not accidental. It is produced by depth, shape, and limited exchange. The vertical walls restrict the easy sweeping movement that would flatten or mix a shallower basin. The narrow opening to the wider lagoon, though broad to the eye, is small compared with the volume below. Tides may breathe across the top, but their energy weakens downward. Wind may touch the surface, but it cannot easily comb the floor. Sunlight may enter, but it thins into blue silence. So the Blue Hole becomes layered in more than one way. It has layers of rock history. It has layers of water chemistry. It has layers of living abundance. It has layers of sediment. Each layer depends on the others, and each one helps explain the next. The old limestone allowed the cave allowed collapse. The collapse made the shaft allowed still water allowed sediment to remain, sediment allowed memory. This chain is quiet, but it is strong. It is the kind of cause and effect that makes geology feel almost intimate. A process from tens of thousands of years ago still shapes what a particle does this morning. A roof that fell in the ancient past still decides where coral grows today. A glacial sea level far below the present shore still lingers in the shape of the water. That is the reason this place feels out of time. It is not old in one simple way. It is old in layers. The living surface belongs to the present day. The flooded cave belongs to a lower sea. The limestone itself belongs to older marine worlds, when shells and skeletons became rock. The sediment at the bottom belongs to every storm, calm season, and changing reef that has passed above. All of these times overlap in one blue circle. As we move lower, the archive becomes less of an idea and more of a physical destination. It is somewhere beneath you, unseen but waiting. The bottom is not a hard floor like polished stone. It is likely soft with fine sediment, mixed with carbonate mud, organic material, and fallen grains from the reef. Some of that material may have arrived yesterday. Some may have rested there for centuries. Some may have been compacted beneath newer layers until it no longer resembles the loose dust that first fell. In a quiet basin, the floor is not a single surface. It is the top page of a thickening book. The newest layer is always exposed. The older layers are hidden below, and the blue hole continues to write downward, not with ink, but with settling matter. This makes the place unusually valuable to scientists who study past environments. A reef tells its own kind of history through coral skeletons and growth bands. A lagoon tells another history through sand, shells, and shifting beds. But a deep sinkhole inside a reef may preserve a more protected sequence. It can hold material from the rim and from the water above in a place less disturbed by everyday wave action. That does not mean the record is easy. Natural records rarely are. A storm layer might be clear in one core and faint in another. A chemical signal might come from more than one cause. A period of low oxygen might preserve material differently from a period of better mixing. Even the walls can contribute particles. Falling limestone fragments or carbonate grains from ledges can interrupt the slow background settling. The archive is not a perfect diary. It is a landscape made of evidence, and evidence needs context. That context begins with the rim. Around the upper edge, the coral reef is not just decoration. It is the living source of much of the material that enters the hole. Corals produce calcium carbonate skeletons. Algae bind, bore, and break carbonate surfaces. Parrotfish scrape reef material and turn some of it into fine sand. Mollusks, tiny foraminifera, echinoderms, and other organisms add their shells and fragments. The reef is always making solid matter from seawater chemistry and living growth. It is also always breaking itself down into grains. This is one of the soft paradoxes of coral landscapes. They build by growing. They also make sand by wearing away. The white sand of tropical lagoons is often the reef returned to fragments. Around the blue hole, those fragments can drift toward the edge. A slight current carries them. A storm surge lifts them. A wave pushes them over the rim. Then gravity takes over. A grain that once belonged to coral structure begins to fall into the old cave. It may take a winding path through the blue. It may settle on a ledge. It may be lifted again by a small movement of water. It may finally reach the lower floor and become part of a pale layer. In that journey, the reef feeds the archive. The living rim gives material to the silent center. This is not loss, exactly. It is circulation in another form. The reef makes calcium carbonate in sunlight. The hole stores it in darkness. Between those two places, the same substance changes meaning. At the rim, carbonate is architecture. In the water column, it is snow. On the bottom, it is memory. That change is one reason the blue hole can feel so meditative. Nothing is wasted in the story. Everything moves from one state to another. Light becomes growth. Growth becomes fragment. Fragment becomes fall. Fall becomes layer. Layer becomes record. And each step is slow enough to be almost invisible. The surrounding atoll adds another scale to this movement. Lighthouse Reef is not a single coral head or isolated patch. It is an offshore reef system with a lagoon, rim, channels, living communities, and surrounding deep water. The blue hole sits within that larger body, receiving influence from it. Water moving across the atoll can carry suspended material. Seasonal changes can alter clarity and temperature. Storms can push water and sediment across the reef flat. Calm weather can allow fine particles to settle. The blue hole is local, but it is never isolated from the wider Caribbean. Its archive is shaped by both its own geometry and the surrounding sea. This is how natural places often work. A small basin can record a broad climate. A cave can preserve evidence of ancient rain. A coral skeleton can hold the chemistry of seawater. A lake bed can remember fire, dust, pollen, and flood. The Blue Hole belongs to this family of quiet record keepers. It is not simply a scenic feature, it is an instrument shaped by geology that measures what passes through it, but it measures slowly. It does not flash or signal, it accumulates. This is why the darkness at the center is not emptiness. It is the visible surface of a hidden process. The deeper blue tells you that material can fall a long way. The steep sides tell you that little of it escapes once it settles. The living rim tells you that the supply continues. The old cave walls tell you that the container came first, and the floor, still unseen below, tells you that time has been gathering quietly. As we drift lower, the wall may become more present. A vertical face of limestone emerges through the blue, not brightly lit, but suggested. It may not be smooth. Old cave systems are irregular. Dissolution creates pockets, scallops, ledges, and undercut shapes. Collapse creates broken surfaces and steep scars. Marine life later colonizes some places, especially where light and water movement allow it. So the wall is not only a boundary, it is another record of transformation. Near the upper part, life can cling to it. Sponges may filter water where currents pass. Algae may cover illuminated surfaces. Small fish may use roughness for shelter. Lower down, the living cover becomes thinner. The limestone shows more of its older form. Here, the wall belongs less to the reef and more to the cave. This shift gives the descent a subtle change in mood. Above, the Blue Hole is framed by tropical abundance. Below, it becomes a geological interior, not a cave in the old air-filled sense, but the remains of one. The sea has softened the boundary, but not erased it. You are still inside a collapsed cavern. You are still moving through a space that began underground. That thought changes the color around you. The blue is not merely marine. It is the sea, occupying a former absence in stone. Every meter downward is a movement through old emptiness. It is also a movement through former air. The stalactites prove this with quiet certainty. Some are found at depth, hanging where cave ceilings once existed. They show that the chamber was open to air long enough for mineral forms to grow. Their presence underwater is like finding a dry forest's roots beneath a lake. It tells you the environment changed completely. It tells you the feature crossed from one world into another. A stalactite cannot hurry. Its growth requires repeated dripping, evaporation, or CO2 loss, and mineral deposition over long periods. The water that forms it must pass through limestone, gather dissolved calcium bicarbonate, and then release calcite in the cave air. This process depends on airspace. It depends on a ceiling. It depends on gravity pulling drops downward. When sea level rose and submerged the cave, that process ended or changed beyond recognition. The old stalactites stopped being active formations in air. They became submerged evidence. They now hang in a world that contradicts the conditions that made them. This is one of the strongest reveals in the Blue Hole's story. The water today is not the maker of every shape inside it. Some of the most important shapes were made before the water arrived. The modern sea is a caretaker of older forms. It holds them in blue suspension. It lets us see, if we know how to read them, that the present is not the only possible state of a place. The Blue Hole was once dry enough for cave decoration. It was once open enough for air. It was once part of a lower world, before the Caribbean returned. Now, those same mineral forms exist below a tropical lagoon. The mismatch is not dramatic. It is beautiful. It is the beauty of conditions changing slowly enough to preserve their own contradiction. As we continue, the water may grow hazier in imagination. This is not the bright haze of stirred sand at the shore. It is a subtler veil, where particles and chemistry mark a transition. In some blue holes, sharp changes in oxygen or salinity create visible layers. A cloudy zone can form when chemical reactions and suspended particles gather near a boundary. Below that, the water may be darker and less hospitable to many familiar reef animals. Again, the important fact is not danger, it is separation. The old shaft allows water to stack. The upper layer has more contact with air, light, and reef circulation. The lower layer can become more still, more chemically distinct, and lower in oxygen. This happens because the water below is not easily refreshed. The basin has depth but limited stirring, organic matter falls in, and microbes use oxygen as they break it down. Without frequent mixing, oxygen does not return quickly to deeper water. The lower part becomes a different chamber, made not by stone walls alone, but by chemistry. It is a room within the water. This is another way the blue hole continues to behave like a cave. A cave has chambers. A water column has layers. Inside this flooded sinkhole, the two ideas meet. The walls make the larger chamber. Density and chemistry make quieter rooms inside it. The result is an underwater landscape with invisible architecture. You cannot see every boundary clearly, but the water feels arranged. Above, warm and bright. Below, cool and dim. Between them, a softened threshold. If you imagine lowering a small sensor through the water, it would read these changes more precisely than the eye. Temperature would shift, salinity might show subtle variation, dissolved oxygen could decrease. Light would fall in a curve, losing intensity with depth. Turbidity might change where particles gather. Each measurement would turn the feeling of descent into a line of evidence. Science often does this. It gives numbers to sensations. It shows that what feels like quietness may be a measurable decline in turbulence. What looks like blue darkness may be light absorption. What feels like separation may be density stratification. The wonder does not disappear when measured. It becomes more detailed. A calm place becomes a set of processes working together. And the blue hole is especially good at revealing that combination because its shape is so simple to the eye. A circle, a shaft, a rim, a floor. Yet inside that simplicity, the processes are layered and changing. The more we understand, the more the place refuses to become ordinary. It is not strange because it is unexplained. It is strange because the explanation requires the whole Earth to participate. Ice sheets far away lowered and raised sea level. Tropical rain dissolved exposed limestone. Gravity collapsed a cave roof. Caribbean seawater flooded the opening. Coral organisms built a bright rim. Microbes changed deep water chemistry. Storms delivered thick pulses of sediment. Calm years laid down finer layers. Every scale meets here. Planetary climate, regional sea level, local geology. Microscopic life, a single fallen grain. This is why the blue hole can hold attention without needing movement. It is already moving through time. Not quickly, but completely. Even now, if the morning is calm above, processes continue. Coral polyps respond to light. Algae photosynthesize in shallow water. Fish move along the rim. Tiny plankton drift over the opening. A few particles separate from the reef and fall. Microbes work in the deeper water and sediment. The floor receives another almost invisible addition. The blue hole does not stop. It only appears still because its motions are small and slow. That kind of stillness is different from emptiness. It is a silence full of work. A reef outside may show life through color and motion. The blue hole shows life and geology through patience. It asks you to watch what usually escapes attention: the settling of grains, the fading of light, the layering of water, the quiet conversion of living material into record. As the descent continues, the upper world becomes a source rather than a scene. You can still imagine the pale turquoise lagoon above, but now it functions like the opening of an hourglass. Material from the bright rim slips inward, not all at once, not evenly. Only as conditions allow. A fair day may send only fine background dust. A windy day may move more sand. A major storm may push larger pulses across the rim. These differences matter because they create variation in the layers. A calm interval might leave thin, fine, dark material. A storm could leave a thicker, coarser, paler bed of carbonate sand. A period of unusual rainfall might alter the chemical signals in organic matter or mineral grains. A change in reef community might change the mixture of skeletal fragments. The blue hole's bottom can preserve these differences because it is protected from the everyday reworking that affects shallower places. This is why some researchers look to blue holes for records of past hurricanes. Strong storms have enough energy to move coarse sediment that ordinary waves cannot. When those storm-washed grains enter a protected basin, they may settle as distinct layers. If dated carefully, Those layers can suggest a history of intense storm events. The record is never read casually. A coarse layer could have more than one explanation. But in the right setting, with careful analysis, the pattern can become meaningful. The blue hole, by its shape, offers one of those settings. A nearly enclosed, deep basin in a reef lagoon can catch storm deposits and protect them, so the dark circle that looks calm today may contain the memory of old weather, not as stories of wind or noise, as grains, as thickness, as changes in texture, as a sudden band inside otherwise fine mud. This is one of the most surprising parts of the place. The blue hole's quietness does not mean it has never known disturbance. It means disturbances can leave marks. The calm after the event is what allows the mark to remain. A storm passes, the water clears, the reef resumes its ordinary rhythms, but below, a new layer lies on the floor. The archive has changed. The surface forgets quickly, the bottom keeps the trace. This relationship between disturbance and stillness is important. Without energetic events, some signals would never enter the basin. Without stillness afterward, those signals would not be preserved. The blue hole needs both. It needs a living, changing rim that supplies material. It needs a deep, sheltered floor that can keep it. It is both open and protected, connected and separated, alive at the edge and quiet in the center. That paired nature is the heart of its strangeness. If it were fully open, the record might be scattered. If it were sealed away from the reef, there would be too little new material to tell the story above. Its value comes from the balance between receiving and resting. The rim gives the blue hole its daily supply, while the depth gives that supply time to settle. This is why the upper edge matters as much as the dark center. The living ring is not separate from the archive below. It is the source, the filter, and the changing shoreline of the record. Around the rim, the water is bright enough for coral communities to continue their slow work. The coral animals build calcium carbonate skeletons, one thin layer at a time. They do this in partnership with tiny algae hidden inside their tissues, using sunlight that reaches the shallow edge. That sunlight is strongest near the surface, where the water is clear, warm, and moving gently. Here, the reef has texture. It has ledges, hollows, rounded coral heads, branching forms, sponges, algae, and small passages where fish move in and out. Every surface has a role. Some surfaces catch light, some shelter small animals. Some are grazed by fish, some are bored by worms, sponges, or other tiny organisms that slowly weaken hard carbonate rock. The reef is not a fixed wall. It is an ongoing negotiation between building and breaking. A coral colony grows upward for years. A storm breaks part of it away. A parrotfish scrapes algae and carbonate from its surface. A sponge drills a small chamber into older skeleton. A shell settles, grows, dies, and becomes part of the sediment. All of this happens around the quiet edge of the blue hole. And each act of growth or erosion makes material that may someday drift inward. The rim is alive, but it is also slowly making the floor below. This is one of the gentlest cause and effect chains in the whole landscape. Sunlight feeds algae inside coral. Coral builds hard structure. Reef life breaks some of that structure into grains. Water carries those grains to the edge. Gravity lowers them through the old cave. The archive grows. Nothing in that chain feels large while it is happening. But over centuries, it becomes a visible record. Over millennia, it becomes a deep bed of time. You can imagine a single grain of coral sand beginning in the shallow light. It may be part of a branching coral, a shell, or the skeleton of a tiny foraminifera. For a while, it belongs to the reef as structure. Then a bite, a fracture, a scrape, or a wave turns it loose. It rests on the lagoon floor, pale and small. A mild current lifts it slightly. It rolls toward the rim. For a moment, it pauses near the boundary, where turquoise water becomes blue. Then it slips over. The descent begins. It does not fall like a stone through air. Water holds it, slows it, turns it. It moves downward in a soft diagonal, then straightens, then drifts again. Above it, the reef remains bright. Below it, the shaft waits. That one grain carries a fragment of the rim into the center. It is a small messenger from the living world, and once it reaches the bottom, It no longer behaves like a loose piece of reef. It becomes part of a layer. That layer may mix with organic matter, fine carbonate mud, plankton remains, and tiny mineral particles. Later, another layer settles over it. Then, another. The grain is hidden, it is still there, but now it belongs to the archive. This is why the bottom of the blue hole is not just a place where things end, it is where pieces of the upper world are placed in order. The order is not perfect, but it has direction. Young material above, older material below, recent calm seasons near the surface of the mud. Older storms, older reef changes, and older chemical conditions beneath. A sediment core taken from such a floor is like a narrow descent through memory. The scientist does not read it as a simple story at first. They describe its color. They measure grain size. They identify shell fragments. They analyze chemistry. They look for organic matter, carbonate content, and signs of oxygen conditions. They date sections when possible, using methods suited to the material. Only slowly does the record begin to speak. A pale, coarse band might suggest stronger waves or storm-driven transport. A darker, finer interval might suggest quieter settling, with more organic material. A chemical shift might point toward changing rainfall, evaporation, circulation, or microbial activity. No single clue is enough. But patterns can gather strength. This is how a silent place becomes evidence. Not by giving one dramatic answer, but by holding many small facts in sequence. The Belize Blue Hole is especially useful because its shape encourages that sequence to remain layered. The steep walls reduce the reach of everyday waves. The depth removes the floor from constant shallow disturbance. The lower oxygen can slow some forms of biological mixing. The protected basin catches what moves over the rim. Together, those conditions make preservation more likely than on an exposed reef flat. This does not mean the bottom is untouched. No natural archive is untouched. Small organisms may disturb upper sediment where oxygen allows them. Chemical reactions can blur boundaries. Later events can erode or redeposit earlier layers. A strong pulse of material can cover the floor unevenly. A wall fragment can fall and interrupt the softer record. But even with these complications, the basin can preserve more order than surrounding shallow areas. That is the key. Not perfect memory, better memory. A place can be scientifically valuable because it remembers enough. The blue hole remembers through contrast. Its upper edge changes daily. Its lower floor changes slowly. The reef responds to light, temperature, water quality, and storms. The bottom receives the long result. This difference in pace creates a natural recording system. Fast events above become thin marks below. Slow trends above become broader changes below. The living rim is like the moving hand of a clock. The sediment floor is the face where the motion leaves a trace. As you hover in the blue water, this connection can feel almost invisible. You do not see time moving from rim to floor. You see only a few particles drifting. You see dim water, old wall, and the suggestion of depth. But the process is continuous. Even in complete calm, some material is always settling. Even when the surface looks empty, microscopic remains are sinking. The blue hole is always receiving its surroundings. It receives the reef. It receives weather. It receives chemistry. It receives the slow consequences of sea level, climate, and life. This is why the phrase silent archive fits so well. The place does not keep memory in a hard museum way. It keeps memory the way mud keeps the shape of rain, softly, imperfectly, but with a kind of patience that stone alone cannot have. Around the rim, meanwhile, the ecosystem continues with no concern for being recorded. Small fish move through coral heads in flickering groups. Damselfish guard patches of algae. Wrasses inspect surfaces for tiny prey. Parrotfish graze and leave pale dust behind. Sponges filter the water, pulling in particles too small for the eye. Sea fans and soft corals may bend gently where water movement is enough to feed them. Algae films grow, are grazed, and grow again. Nothing here is still in the way the lower water is still. The rim has a quiet busyness. It is not loud or hurried, but it is full of maintenance. Every organism is performing a small daily task: feeding, filtering, growing, hiding, reproducing, scraping, settling. The reef is a community of tiny continuities, and just a short distance inward, The deep shaft receives what that community releases. The boundary is so narrow that a fish can cross it in seconds. But the environmental shift is profound. On the reef side, structure multiplies. On the center side, structure falls away. On the reef side, sunlight is abundant. On the center side, light becomes distance. On the reef side, water movement refreshes surfaces. On the center side, water slows and separates. That sharp contrast is part of the visual wonder, but it is also the reason the ecosystem changes so quickly. The blue hole is not surrounded by emptiness, it is surrounded by life. Its strangeness comes from the way life approaches the edge and then gives way to depth. This is different from a gradual slope into open ocean. There, habitats may change across long distances. Here, the change is nearly immediate. A shallow coral world becomes a flooded cave shaft. A reef garden becomes a blue well. The eye feels the transition before the mind explains it. That is why the blue hole can seem almost unnatural from above. The circle is too clean for ordinary expectation. The color shift is too sudden. The edge is too definite. But the causes are entirely natural. Karst processes created the void. Collapse opened it. Sea level drowned it. Coral framed it. Still water preserved it. The precision is not artificial. It is the visible outcome of slow processes acting through limestone. Limestone is especially suited to making such features because it dissolves in weak acid. Rainwater does not need to be harsh. It only needs CO2, time, and pathways through rock. Once cracks begin to widen, they guide more water. More water widens them further. This feedback can create extensive underground drainage. Eventually, caves, shafts, and collapse basins form. In tropical carbonate regions, this can happen beneath a surface that looks bright and solid. The land may appear quiet, while the interior is being patiently removed. The blue hole is the marine descendant of that hidden removal. The reef now hides much of the older karst landscape beneath water. But the circle reveals one place where the old void remained open. From above, it is almost like looking through the present into a previous world. The turquoise lagoon is today. The dark center is an earlier landscape preserved by drowning. The circular rim is the seam between them. As the descent continues, the idea of the rim as a seam becomes important. A seam joins two materials. Here, it joins reef and cave. It joins light and depth. It joins construction and collapse. It joins active life and stored memory. The seam is narrow, but it holds the whole identity of the place. If you linger there in imagination, you can see how many processes meet. Coral larvae settle on hard surfaces near the edge. Fine sediment washes over the lip. Small fish hunt along the drop. Sunlight reaches the upper walls. Deeper shadows begin just below. Water moves across the opening, then slows as it enters the shaft. Particles cross the threshold and begin to fall. The rim is not simply the top of a hole. It is a transfer zone. It transfers light into shadow. It transfers reef material into sediment. It transfers surface events into a protected record. It transfers an ancient landform into the modern sea. This is why a landscape can be calm and still feel active. The activity is distributed through time. Some of it happens in seconds, as a fish turns. Some of it happens in hours, as particles settle. Some of it happens in seasons, as storms leave deposits. Some of it happens in centuries, as sediment thickens. Some of it happens in ice age cycles, as sea level moves. The blue hole holds all these clocks at once, and because it is round, deep, and clear, those clocks seem gathered into one simple image. The darker center is not only a color, it is a convergence. The living rim also helps explain why the blue hole remains visually framed. Coral and carbonate sand in shallow water reflect light strongly. The surrounding lagoon appears pale blue or turquoise because sunlight reflects from bright carbonate sediment and shallow surfaces. The central shaft, by contrast, absorbs more light because the bottom is far below. Water itself becomes the color maker. The more water light passes through, the more warm colors fade. The difference between shallow, bright carbonate and deep blue water becomes dramatic. So the famous image is an optical partnership. The reef supplies brightness. The hole supplies depth. Without the surrounding pale shallows, the dark blue would be less sharply outlined. Without the deep shaft, the pale reef would not form that perfect contrast. The scene depends on both. It is a visual form of the same paired nature we have been following. A live edge, quiet center, bright carbonate, deep water. Open surface, protected floor. The atoll holds them together. Lighthouse Reef Atoll itself adds a wide, slow frame to the Blue Hole's story. An atoll is built from reef growth around a lagoon-like interior. It is a structure made by organisms, waves, currents, and sea level over long periods. The reef rim faces the open sea, while the lagoon inside holds quieter water. Within that lagoon, the Blue Hole sits as an older interruption. It was not made by the same reef-building process that frames the atoll. It was inherited from a time when this limestone was exposed and castified. That difference matters because it means the Blue Hole is a feature inside a feature. A geological memory enclosed by an ecological structure. A cave collapse held inside a reef landscape. The atoll is not merely background. It determines what enters the hole now. It shapes water movement. It supplies carbonate sediment. It supports reef communities. It mediates storms, tides, and currents before they reach the basin. In this sense, Lighthouse Reef is both setting and witness. It surrounds the Blue Hole, feeds it, and helps preserve its contrast. The Blue Hole, in return, stores part of the atoll's history. The two are linked. One is bright and living, one is dark and receiving. Together, they make a landscape that is more than either part alone. As you sink a little deeper, the rim becomes less visible, but its influence continues. You may no longer see the coral clearly above, but its grains are still falling around you. You may no longer see fish moving along the edge, but organic traces from the upper water still drift downward. You may no longer feel the warmth of the shallow lagoon as strongly, but that warmth shaped the life that made the sediment. The upper world is present here through what it sends. A deep place can be connected even when it feels isolated. This is true across the ocean. Deep sea floors far from sunlight receive marine snow from the surface. Submarine canyons funnel shelf sediments into deep basins. Estuaries send organic matter into coastal waters. Lakes receive pollen from forests around them. Quiet basins are often connected to busy edges by falling material. The Blue Hole is a smaller, clearer example of that larger pattern. It shows the connection in a single vertical column. Above, creation; below, preservation. Between them, descent. This vertical arrangement is what gives the place such dreamlike clarity. A grain can move from a sunlit coral surface to a dark archive without leaving the circle. A storm can pass above and leave a layer below. A change in water chemistry can be recorded in mud. A living reef can become a geological record almost immediately. The Blue Hole shortens the distance between life and history. It lets the present fall straight into the past. That sentence sounds poetic, but it is also literal. The newest material lies on top of the older sediment. Each falling particle becomes part of the latest surface. The past is below because gravity places it there. This is the simplest logic of sedimentary records. Down is older, up is younger. The Blue Hole turns that logic into a visible descent. As we move lower in imagination, we are not only going down through water, we are approaching older and older layers beneath the floor. We are nearing the place where recent particles come to rest on centuries of previous arrivals. The water column itself is the path between now and then, and the more still it becomes, the easier it is to feel that path. A particle falling beside you may have separated from the reef this morning. Below it may lie grains from storms before anyone mapped this atoll in detail. Below those may lie material from centuries of changing sea conditions. Deeper still, the sediment may preserve signals from times when the reef, climate, or surrounding waters differed in ways now hard to imagine. The exact layers require careful study, but the principle is enough to hold the mind. The bottom is not merely below, it is before. This is why the descent feels like time travel without leaving the water. The Blue Hole has already carried us backward once, to the cave before the sea. Now it carries us backward again, through the sediment accumulating after the sea returned. There are two kinds of memory here. The walls remember the dry cave, the floor remembers the flooded reef. The walls are memory in stone shape, the floor is memory in settled layers. The walls tell of dissolution, air, stalactites, and collapse. The floor tells of water, storms, reef fragments, chemistry, and time after drowning. Together, they make the Blue Hole a double archive. One archive is vertical rock, the other is soft sediment. One formed before the sea filled the basin. The other has been forming because the sea filled it. This is part of why explaining the Blue Hole does not make it less strange. Each explanation reveals another record beneath it. You think the circle is the mystery? Then the cave explains the circle. You think the cave is the story. Then the drowned stalactites reveal changing sea level. You think the sea level change is the story. Then the water layers reveal a hidden interior climate. You think the still water is the story. Then the floor reveals an archive of reef and weather. The place keeps deepening, not by becoming more dramatic, but by becoming more connected. The more you know, the more every quiet feature matters. A color boundary becomes depth. A coral rim becomes sediment source. A cloudy layer becomes chemistry. A soft floor becomes record. A stalactite becomes proof of former air. A circular shape becomes collapse over void. The Blue Hole teaches through relationships. Nothing stands alone. Even the darkness depends on sunlight entering from above. Even the stillness depends on the shape of walls. Even the archive depends on disturbance at the rim. This is the gentle complexity of natural landscapes. They are not puzzles with one answer. They are systems, and every answer is a connection. As the water darkens, the human sense of scale shifts again. At the surface, 300 meters across, is a visible circle. From within, that width becomes spaciousness. The far wall may fade into blue. The near wall may appear only when you drift close enough. The bottom remains implied, not seen. The shaft has enough room to feel open, but enough boundary to feel contained. This in-between feeling is central to the Blue Hole. It is not the open ocean, it is not a closed cave, it is a flooded room, wide enough to breathe in, and deep enough to keep its own quiet. That middle condition shapes everything you feel as you continue downward. The walls do not disappear, but they no longer belong to the bright reef world above. They become the sides of an old limestone memory, softened by water, shadow, and time. If the surface was a circle, the interior is a column. And if the rim was the question, the lower water is where the answer becomes slower. Here, the Blue Hole's strangeness is less visual and more physical. It is not only what the eye sees, but what the water does. It rests, it separates, it keeps what falls into it. A shallow lagoon is constantly being revised by light, waves, and small movements across the bottom. The Blue Hole, by contrast, has depth enough to protect part of itself from that daily revision. This does not mean it is sealed. It breathes with the sea at the top. But deeper down, the breathing becomes faint. The opening above is wide to us, yet small compared with the full volume of the shaft. So the upper water can change quickly, while the lower water changes with more hesitation. That hesitation becomes part of the place. It allows the sediment to settle, it allows chemical layers to form, it allows evidence to remain where it lands. The deeper Blue Hole is shaped by slowness as much as by stone. Imagine lowering through the water with no need to hurry. The light above is still present, but it has lost its sharpness. The bright Caribbean surface has become a pale, trembling ceiling. The rim is now only an idea behind and above you. The living coral is no longer the main image. Instead, you are inside the old shaft, where the water's own structure matters. A faint haze may gather in the distance. It is not fog exactly, but a change in clarity. Tiny suspended particles, microbial processes, and chemical boundaries can make deeper layers seem veiled. In a place like this, even a slight change in density can become visible. Water that differs in temperature or salinity may resist easy mixing. A boundary forms, gentle but real. Above it, the water belongs more closely to the reef. Below it, the water belongs more closely to the well. That boundary is not a line painted across the blue. It is a transition you pass through slowly. It may be only a subtle dimming, a soft milkiness, a feeling that the water has thickened, but scientifically it matters. Such layers can influence oxygen, microbial life, and the way particles settle. They can help determine what reaches the floor and what changes on the way down. This is where the blue hole becomes an interior ecosystem, not only a geological form. There may be fewer visible animals here, but the water is not inactive. Microbes can live where larger reef creatures do not thrive. They use the chemistry available to them. They help transform falling organic matter into dissolved compounds, gases, and darker sediment. In oxygen-rich water, decay follows one set of pathways. In oxygen-poor water, it follows another. So a particle that falls from the reef does not arrive unchanged. It enters a series of small transformations. It may be nibbled, it may be colonized by microbes, it may partly dissolve, it may clump with other particles. It may darken as organic material breaks down. By the time it reaches the bottom, it is no longer only a piece of the surface. It is a piece of the surface that has been translated by depth. This is a quiet but important reveal. The blue hole does not simply store material like a jar, it alters material as it stores it. The archive is shaped by the journey as much as by the arrival. That journey is vertical, and the vertical is what makes the blue hole so unusual. Most shallow reef sediments move sideways. They are pushed by waves, tides, and currents. They shift across sand flats, collect behind coral heads, or wash through channels. Here, once a grain crosses the rim, gravity becomes more important than horizontal motion. The grain has entered a different system. It is no longer traveling across the reef, it is falling into the past. You can think of the blue hole as a kind of natural settling chamber. The rim supplies, the water filters, the floor records. But each part of that simple sequence has detail inside it. The rim does not supply the same material every day. Calm weather may send only fine carbonate dust, plankton shells, and tiny organic fragments. A windy week may move more sand across the shallow edge. A strong storm may carry coarser reef debris into the opening. A season of warmer water may change plankton communities. A period of heavier rainfall may affect nearby coastal waters, salinity, and nutrients. Even if those changes are subtle, some may leave faint signals in the sediment. That means the floor can contain both sudden layers and slow trends. A sudden layer might be a pale band of coarser carbonate sand. A slow trend might be a gradual shift in organic content or grain size. Both kinds of evidence matter. One records an event, the other records changing conditions. And the blue hole, because it is sheltered, can sometimes preserve both. This is why scientists treat places like this with care. A sediment core from the bottom is not just mud. It is a vertical sequence of arrivals, each shaped by the water column and the basin floor. The uppermost material is usually the youngest. Deeper material is older, pressed under the weight of what came later. If the layering remains clear, the core can offer a timeline, but the timeline must be built slowly. Researchers may study texture first. They look for coarse grains, fine mud, shell pieces, and changes in color. Then, they may examine chemistry. They may measure carbonates, organic matter elements, isotopes, and signs of oxygen conditions. They may date shells or organic remains when the material allows it. Each method adds another soft light to the record. No single measurement explains everything, but together, they can turn the silent floor into a history of the reef and sea above. This is the consequence of the blue hole's stillness. The same stillness that makes the center look empty also makes it useful. If the floor were constantly churned, the layers would blur. If the basin were too open, storm material might pass through and vanish. If no material arrived, there would be nothing to read. But the blue hole has the rare balance of receiving and protecting. It is open enough to gather evidence. It is sheltered enough to keep some of it in order. That balance comes directly from its shape. The steep walls were born from collapse. The depth came from the old cave void. The rim was drowned by rising sea level. The modern reef grew around the opening. Every later process depends on those earlier steps. So when a grain settles on the bottom today, it is obeying a form made long before the present sea. That is the deep cause and effect of the place. The past does not sit behind the present. It still acts through it. The old collapse decides where sediment goes now. The old cave decides where oxygen becomes low now. The old sea level fall decides where the modern reef has a dark center now. This is why the Belize Blue Hole is not only beautiful from above, It is scientifically strange from within. It is a natural instrument built by accident. It records because of its geometry. It separates water because of its depth. It shows former air because of its stalactites. It reveals sea level change because the cave is now underwater. The more closely you follow it, the more the circle becomes a chain. Rain made hollows. Hollows weakened roofs. Collapse opened the shaft. Rising sea filled it. Reef life framed it. Falling matter preserved it. And now, as we continue toward the deeper floor, all of those causes gather beneath you. The water feels less like a passage and more like a long pause. The surface is no longer the place you are in. It is only the source of the light. The reef is no longer beside you. It is only the source of falling grains. The wall is no longer a boundary to swim around. It is the old limestone story holding the water in place. Below, the floor begins to matter more. You may not see it clearly yet. It is still too dim, too far, too softened by suspended particles. But everything in the descent is leading there. The bottom is where the blue hole's shape turns into memory. At the floor, the falling stops. The archive begins. Near the bottom, the water can feel more withdrawn. The pressure is greater because the column above has grown taller. The light is weaker because the path from the surface is longer. The oxygen may be lower because renewal is slower and decay continues. The sediment is finer because the heaviest pieces may have settled earlier or collected near slopes and ledges. But the floor is not a blank surface. It is an accumulation. It has texture, even if that texture is soft. Fine carbonate mud may lie like pale dust. Organic rich material may darken some layers. Coarser storm bands may interrupt the quieter background. Small fragments from the wall may rest where they fell. Each kind of material has a source. Each source points back upward, outward, or backward in time. A pale grain may have come from coral. A tiny shell may have belonged to plankton. A darker fleck may have been algae, seagrass, or microbial matter. A larger piece may have broken from the wall. A coarse layer may have been carried in during unusual wave energy. The bottom is not one story. It is many small stories lying together. And yet, from above, all of that becomes simply dark blue. This difference between appearance and process is one of the quietest wonders of the blue hole. The eye sees depth, science finds sequence. The eye sees stillness, science finds chemistry. The eye sees a circle, science finds climate, sea level, cave formation, reef growth, and time. Understanding does not remove the mystery. It gives the mystery a shape. The floor is where that shape becomes thick. Layer after layer, the blue hole has been receiving the surface for thousands of years. Not every year leaves a clear line. Not every event survives. But enough can remain to make the basin a rare record. A storm that crossed the atoll centuries ago may have left a band. A quieter period may have left finer mud above it. A change in reef production may have altered the carbonate fragments. A shift in oxygen may have changed how organic matter was preserved. The bottom keeps these signals not because it chooses them, but because the water above is slow. Stillness is preservation, and preservation is a kind of memory. Now, the descent becomes more inward, not more dramatic, only more focused. We have followed the blue hole from the living rim into the dim center. We have followed rain into limestone and seawater into the collapsed cave. We have followed particles from coral light into lower shadow. Now the remaining movement is toward the soft record itself. The floor is not far in the imagination. It waits below as a gentle plain, uneven in small ways, but broad compared with any single grain. It is not a floor built for footsteps. It is a floor made of settling, a place where motion loses energy, a place where fragments of reef, weather, and water finally rest. In the deepest part, the blue hole is not trying to resemble the reef above. It has another role. It receives what the reef cannot keep. The upper edge grows, breaks, and renews. The bottom gathers, compresses, and hides. That difference in role gives the whole feature its strange wholeness. The rim is the present tense, the floor is the stored past, the water between them is the slow grammar of descent. This is why the blue hole feels like a vertical sentence. It begins with light, it passes through blue. It ends in sediment, and each falling particle adds another word. The deepest sediment may include long histories of storms moving through the Caribbean. Researchers studying blue holes and similar sheltered basins often look for storm deposits because storms can move sediment with unusual strength. In ordinary conditions, only fine material may drift over the rim. During stronger events, waves and surge can lift coarser carbonate sand and carry it into the basin. When that coarser material settles, it can create a distinct layer. If such layers repeat through a core, they may suggest periods of more frequent intense storms. But this kind of interpretation requires patience. A coarse layer must be tested against other possibilities. Was it truly from a storm? Could it be from wall collapse? Could it be from local reef change? Could later disturbance have moved it? Science asks these questions slowly, because natural evidence is rarely simple. The blue hole gives clues, not instant answers. That makes it more honest as a landscape. It keeps the past, but it does not simplify it for us. The difficulty of reading the archive is part of its beauty. It reminds us that the natural world does not arrange itself into easy explanations. It preserves overlaps, interruptions, and partial signals. A storm layer may be sharp in one place and thin in another. A chemical boundary may shift over time. Sediment may collect unevenly across the basin floor. The bottom may slope slightly toward deeper pockets. The walls may shed material in local patches. So a single core is a narrow window. Several cores can provide a broader view. The record becomes clearer when multiple lines of evidence agree. This careful work turns the blue hole from a famous image into a measured environment. Its strangeness becomes testable, its beauty becomes data without ceasing to be beauty. The same circle that draws the eye from the sky also draws instruments, samples, and questions downward. How fast has sediment accumulated? Which layers mark storms? How has oxygen changed in the lower water? What does the chemistry say about rainfall, salinity, or reef productivity? How stable are the water layers? How much of the archive is continuous, and how much is interrupted? These questions do not disturb the calm. They deepen it. They show that still places can hold complex histories. They show that darkness can be full of information. The bottom of the blue hole is strange, because it is both ordinary and extraordinary. Ordinary, because sediment falls and settles in basins everywhere. Extraordinary, because this basin is a drowned cave inside a coral atoll. Ordinary, because carbonate grains come from reefs. Extraordinary, because those grains fall into a shaft more than 100 meters deep. Ordinary, because mud preserves environmental signals. Extraordinary, because this mud rests beneath a perfect-looking blue circle in tropical water. The processes are familiar, the arrangement is rare. That is often how geological wonders work. They do not need impossible ingredients. They need familiar ingredients placed in an unusual sequence. Limestone, rain, collapse, sea level rise, reef growth, still water, sediment. Each is natural. Together they make the blue hole. As you continue lower, the wall may fade again. The darkness near the floor does not feel empty now. It feels full of what has arrived. The sediment is not glowing. It does not announce itself. It simply waits, holding the faint record of everything above. A piece of coral sand from the rim, a shell from a drifting organism, a dark thread of organic matter, a storm-delivered band. A chemical trace of low oxygen, a mineral grain altered by the water's quiet reactions. All of these become the floor. If you could place your hand just above it, without stirring anything, you would be near the newest layer of the blue hole's memory. The surface of the mud is the present arriving. Beneath it, the past begins immediately. There is something peaceful in that order, not because it is perfect, but because it is gentle. The bottom does not rush to explain. It keeps receiving. It lets the newest material rest on what came before. It allows weight and time to press soft arrivals into older layers. It makes history without needing to know it is history. The deeper blue hole also reminds us that absence can be creative. The original cave was made by removal. Limestone dissolved and left open space. Collapse removed the roof and made a visible basin. The sea filled the absence with water. The reef grew around but not across the central void. The void then became a place where sediment could gather. So the blue hole's emptiness is not empty in its consequences. Because space existed, water could enter. Because water entered, light could fade into blue. Because depth remained, layers could separate. Because the floor was protected, sediment could preserve. Absence became structure. That is one of the most quietly powerful ideas in the whole landscape. The whole matters because something is missing. The missing limestone created the form. The missing roof created the opening. The missing shallow bottom created the dark color. The missing circulation created the stillness. The missing oxygen in deeper layers shaped preservation. This is a place made by what is not there, and yet what is not there makes everything else possible. The living rim would not appear so bright without the dark center beside it. The archive would not form without the vertical void to catch it. The stalactites would not be meaningful without the vanished air that made them. The sea level story would not be visible without the drowned cave. The blue hole is a landscape of vanished conditions, still leaving active effects. This is why it feels ancient, even under morning sunlight. Its present beauty is built on earlier disappearances. A lower sea level disappeared. A dry cave disappeared. A roof disappeared. Air-filled chambers disappeared beneath water, but the consequences remain. The circle remains. The walls remain, the formations remain, the layered water remains, the sediment keeps arriving. The word strange becomes softer here. At first, strange meant visually surprising, a dark blue circle inside pale turquoise water. Then strange meant geologically unexpected, a dry cave hidden beneath a reef lagoon. Then strange meant chemically layered, a water column with its own interior zones. Now strange means archival, a beautiful place that also quietly records change. Each meaning adds to the others. None replaces the first impression. If you were back above, looking down from the surface, you would still see the circle before anything else. But now the circle would not seem simple. It would hold the cave. It would hold the collapse. It would hold the rising sea. It would hold the living rim and the silent floor. The image would have depth in the mind, not only in water. That is what explanation gives to wonder. It lets the eye see more than shape. It lets the calm surface become transparent to time. As we near the bottom, the pace must slow even more. Not because anything is ending, but because the lower blue hole asks for smaller attention. Here, a single pale grain matters because it has crossed every boundary the blue hole can offer. It began in sunlight, perhaps as part of a coral skeleton or a shell no wider than a fleck of dust. It loosened, drifted, passed over the rim, and entered the older space below. Now, near the floor, it joins other grains that arrived by different paths, in different seasons, under different skies. Some came during calm weather, when the water above was clear and the reef released only a faint daily powder. Some came during stronger waves, when the lagoon was stirred and heavier sand moved farther than usual. Some may have come from the wall itself, small pieces of limestone surrendering to time. Together they make a surface that is soft, but not simple. The bottom is not a blank ending. It is the place where the blue hole becomes legible. If you could see the floor clearly, it might not look dramatic at first. There would be no sharp monument, no single object explaining everything. There would be fine sediment, pale in some places, darker in others, lying in quiet unevenness. There might be subtle slopes where material has settled differently across the basin. There might be fragments from the walls, resting where gravity placed them. There might be layers hidden just beneath the surface, too thin to see without careful sampling. The most important parts of the floor are often not visible from above. They are held in thickness, they are held in order, they are held in the difference between one quiet layer and the next. This is the final reveal of the Belize Blue Hole. Its deepest strangeness is not only that it is a flooded cave, or a round blue well, or a reef-ringed sinkhole. It is that the same form which makes it beautiful also makes it remember. The circular collapse created a basin. The basin slowed the water. The slow water allowed particles to settle. The settled particles made layers, and the layers kept traces of weather, reef life, chemistry, and time. The blue hole is strange because its shape turns passing moments into sediment. A storm that lasted a day may become a band only a few centimeters thick. A A calm century may become a slow accumulation of fine mud. A change in oxygen may alter the color, texture, or chemistry of what is preserved. A shift in reef growth may change the grains arriving from above. Everything that reaches the bottom has already been translated by water, but something of its origin remains. This is why the floor is not empty, even when life is sparse. It is full of consequences. The old cave walls tell one part of the story, in stone. The sediment tells another, in softness. The walls remember a time before the sea. The floor remembers the sea after it arrived. Together, they complete the long chain. First, ancient marine organisms helped make carbonate rock. Then lower sea levels exposed that rock to air and rain. Then weak acid in rainwater widened cracks, making caves inside the limestone. Then mineral drops formed stalactites in open chambers. Then the roof weakened and collapsed, opening a round sinkhole to the sky. Then the Ice Age ended, and the Caribbean rose across the platform. Then seawater entered the hollow, drowning the cave formations. Then coral and reef life framed the rim in warm light. Then particles began to fall, slowly, continuously, into the still interior. And now, at the bottom, all of those earlier events still matter. Nothing has been erased completely. It has only been covered, flooded, softened, or buried. That is the aftermath of the Blue Hole's making. A vanished landscape remains active beneath a living one. You can feel that here, in the darker water. The pressure is steady, the light is thin, the surface is no longer a place, but a pale memory overhead. The reef is no longer visible in detail, but its material is all around you. The old cave is no longer dry, but its shape holds the water like a quiet vessel. The Blue Hole has become a meeting point of absences. The vanished limestone is present as space. The vanished roof is present as a rim. The vanished air is present as drowned stalactites. The vanished lower sea level is present as a cave beneath the modern Caribbean. The vanished storms are present as bands in mud, and the vanished days of the reef are present as grains lying on the floor. This is why the place remains strange, even after its causes are named. Explanation does not close the circle, it opens it downward. Near the bottom, the sediment receives another falling particle. It may be too small to notice, it may settle without stirring anything visible, but it still changes the floor, however slightly. The newest layer grows by almost nothing, and that almost nothing is how geological records are made. A basin like this does not need to transform quickly. It only needs to keep receiving. It only needs the rim to shed grains, the water to slow them, and the floor to hold them. Over years, that becomes a film. Over centuries, it becomes a bed. Over millennia, it becomes an archive thick enough to question. A scientist may someday lift a core from this floor and find the trace of an old storm, or a shift in oxygen, or a change in reef sediment, or a pattern that is still uncertain, waiting for comparison with other records. The Blue Hole gives evidence, but not always certainty. It keeps enough to invite questions. It withholds enough to remain itself. That is part of its calm power. It is readable, but never completely read. The answer to why the Belize Blue Hole is so strange is not one answer. It is a sequence. It is strange because it looks like open sea, but it began as dry limestone. It is strange because it is inside a reef lagoon, but its main shape was made before the reef surrounded it. It is strange because its darkness is not shadow, but depth. It is strange because its walls hold cave formations made in air. It is strange because its water can layer quietly, separating the bright upper world from the dim lower one. It is strange because the living rim continues to feed the silent floor. And it is strange because the bottom preserves traces of events that have already vanished from the surface. Each cause leads to the next. Each layer makes the whole place more complete. A cave becomes a sinkhole. A sinkhole becomes a blue well. A blue well becomes a reef-framed archive. And the archive continues, grain by grain, beneath the morning water. Now the descent no longer needs to go farther. The floor has arrived beneath you as a soft boundary, not a hard stop. It is the bottom of the shaft, but not the end of the story. Below the uppermost sediment are older layers, pressed gently under newer ones. Below those are still older arrivals, from earlier storms, earlier reef conditions, earlier centuries of Caribbean weather. And beneath the sediment, somewhere deeper in the buried structure, is the broken limestone of the collapsed cave. The bottom is layered downward in the same way the water is layered above. Recent surface, older mud, fallen rock, ancient hollow, carbonate platform. Each level belongs to a different time. Each time remains physically present. This is what makes resting here feel different from simply reaching a depth. You have reached a place where time has become material. The blue hole from the sky is a circle. From the rim, it is a sudden change in color. From the water, it is a vertical room. From the walls, it is a drowned cave. From the sediment, it is a record still being written. No single view is wrong. Each one is only incomplete. The full place requires all of them together. The bright shallows, the old limestone, the collapsed roof, the rising sea, the quiet layers, the living rim, the settling floor. That is why the blue hole stays in the mind. It is simple enough to see at once, and deep enough to think about for a long time. Its beauty is immediate, its meaning descends slowly. Above, the Caribbean continues to move in small ways. Light touches the lagoon, fish cross the coral edge, a current shifts grains near the rim. The atoll holds its pale water under the morning sky. And here, far below that brightness, the floor remains still enough to keep receiving. The blue hole does not need to announce its work. It does not need to be more mysterious than it is. Its mystery is already built into the way a dry cave became a marine well, and the way a marine well became a memory of the reef. The explanation settles around you like fine sediment. Not heavy, not final, just present. You are resting now at the bottom of the blue. The water above is a tall, quiet column. The rim is far overhead, bright with life you can no longer see. The cave walls stand around this darkness, holding the shape of a vanished world. Beneath you, soft sediment lies in thin, patient layers. Some grains came from coral, some came from storms. Some came from chemistry working in low light, some came from the slow wearing of the walls. All of them have arrived here, where movement becomes rest. The Belize Blue Hole is still collecting. It is still separating light from darkness, reef from archive, present from past. It is still holding the proof that sea level changed, that stone dissolved, that roofs can vanish, and that water can preserve what it covers. Tomorrow, another grain will fall. Another particle will turn through the dim blue, another trace of the living rim will settle onto the quiet floor, and the circle above will look almost the same, dark in the center, pale at the edge, calm under the sky, but here at the bottom, the record will be slightly different, a little thicker, a little deeper, a little more complete, and still unfinished. The blue hole has explained much of itself, but not everything. Some layers remain unread, some signals remain uncertain. Some old storms, old waters, and old silences are still folded into the mud. And so the blue circle keeps listening, beneath Lighthouse Reef, holding its calm shape over questions that have not yet risen to the light.